Hi, today's video is going to be about transformers. Sometimes I forget that some of the most basic and fundamental things that we deal with all the time that have to do with NuTone Intercom systems get overlooked because I forget that not everybody knows what I know. So today we're going to do a really quick video, I think it'll be quick, about how you test your NuTone transformer. So this is a NuTone transformer. This is a model 301T, and this is going to be the subject of our video today. This video and what I'm going to show you applies to all NuTone transformers. It doesn't matter which one you have, whether it's a 301T like this one, or a 105T, or a 401T, or an 801T, or some of the other odd ones that you rarely see anymore nowadays. But the basic information and what I'm going to show you and how to test it applies to all NuTone transformers. Like all my videos, you're not going to get away with just a quick this is how you do it thing. First, you're going to have to learn a little bit about how transformers work, because that will make it make more sense to you by the end. At least I hope it does. So let's go to the whiteboard. Transformers are one of the very greatest inventions ever that have to do with electricity. They allow you to do a lot of really interesting things in a lot of interesting ways, and they're a fairly simple, although they can be complicated, device. The anatomy of a transformer is pretty simple. You have a core of some type, usually it's steel or sometimes iron, and it can be a solid piece of steel or iron, or it can be lots of thin sheets laminated together in usually some sort of rectangular or square form, and the center is hollow. On one side you have the primary side, and on the other side you have the secondary side. The primary side is where the power going into the transformer connects, and the secondary side is where the power coming out of the transformer exits. On each side, wound around the core of the transformer, there'll be a single small wire that's wrapped around and around and around and around the core, covering it up, and that's what these red lines represent. So these are the primary windings because they're wound around the core. And on this side you have another wire that's wound around the core, and this is the secondary windings. So the way this works is pretty simple. If you remember back to your elementary school science class, if you wind a wire around a metal core and put electricity through it, what you've created is an electromagnet. And when you have an electromagnet, it creates a magnetic field. And you might remember also, I remember it from when I was in 6th grade science class, we had these metal bar magnets with north and south stamped on the ends for the different poles, and the teacher had us put them under a piece of glass or plastic that was clear, and then you pour some iron filings on top of the plastic and you tap on them, and the filings scoot around and you can see the magnetic field that's coming out of the ends of the magnets. That's the same thing that happens here. When you pass electricity through the windings that are wound around the core of the transformer, it creates a magnetic field. Now, the magnetic field is only generated from the electricity that's coming in on the primary side, and if we were to draw the magnetic field in, it would look something like this. And this is not terribly accurate, but it gives you sort of the general idea of the magnetic field. And the magnetic field always goes in one direction. So all of these are going, we'll say, bottom to top, like this. So we're passing electricity through the windings on the primary side, which creates an electromagnetic force because the wire is wound around the metal core, and we've created this magnetic field. And the field actually comes out on the left-hand side just as much as it does on the right-hand side, but that doesn't really make any difference for how the transformer works. It's just an extra field on that side. Now, you might wonder how the electricity comes out of this side. How does it exit on the secondary side? Well, it's actually pretty easy. When you have a magnetic field that's generated by the primary side, it impacts or inducts or induces or bleeds into the windings on the secondary side. So the energy from the magnetic field on the primary side impacts the windings on the secondary side, which then has its own magnetic field. And the magnetic fields essentially run into each other. So the left-hand magnetic field from the primary side bleeds towards the right, and it inducts or induces or bleeds into the windings on the secondary side, which the energy creates another magnetic field, and that's how the energy from the primary side gets transferred through the core out of the secondary side. You might be thinking, well, who cares? Well, it's important, because one of the important aspects of transformers is, if you look at the drawing, there is actually no electrical connection between the primary side and the secondary side. The windings on the primary side don't ever touch the windings on the secondary side. Yes, they are wrapped around the same core, but that doesn't make any difference because the wires are insulated. They're covered with enamel usually, which insulates them, just like the plastic or vinyl insulation on wires that you may have seen here and there in your house. So they're not electrically connected. The only way that they're connected is through the magnetic field that the coil generates here and the magnetic field that the secondary coil receives. So they're completely isolated. You could actually, if you wanted to, you could draw a line down the middle as a theoretical barrier. It can't be metal, it has to be something else. But they're actually two separate halves. They don't actually ever touch. The only parts that actually touch are the two magnetic fields. And you might think, well, that's crazy. How can that possibly work? So there is a real world example that many of you may be able to identify with. A lot of people use cordless toothbrushes, and they sit in a little stand on your counter in your bathroom, and you pull it up, you brush your teeth, and when you're done, you put it back down in the stand, and it charges back up all on its own. And if you take the toothbrush out of the stand and look on the bottom, there's nothing there. It's just plastic on the bottom. There's no little metal contacts, or there's no little metal contacts down in the base. It's all just plastic, and it's like it's magic. And it kind of is magic, although it's not. What you have here is you have two halves of the transformer. One half of the transformer is in the base that sits on your countertop, and the other half of the transformer is in the bottom of the toothbrush handle. So you can think of it as this side to the left of the green line. This is the toothbrush base that sits on your countertop, and it's plugged into a wall plug, and it's creating the magnetic field. And this side on the right is the bottom of the toothbrush handle, and it has its own coil in it also, the other half of the transformer. And when you sit the brush down in the base, you're putting the two halves of the transformer next to each other, and the magnetic field from the primary side is bleeding into the coils in the secondary side in the toothbrush handle, and it's charging up the battery. Now there's electronics and stuff over here that isn't part of this video, and batteries, but that's how it works. So it's not magic, it's through induction, or it bleeds through. You're putting the two magnetic fields together, and that's how it charges up the battery, which is pretty interesting. Okay, so more specifically back to the NuTone transformers, now that maybe you understand about the magnetic field idea. How does the transformer know how much voltage to make? Because we're going to power a NuTone Intercom system. Now, most NuTone Intercom systems, for the most part, we're going to generalize, but the majority of them operate on 16-volt transformers. So our secondary voltage on the secondary side of the transformer is going to be 16 volts. The primary side, the part that's wired into your house electrical system, generally speaking, it varies a little bit from area to area in the United States, but generally speaking, primary voltage in house wiring nowadays is 120 volts. Some places it might be a little less, could be 115, some places maybe even 110 still, but we're just going to go with 120 to make the math easy. So how does the transformer, how does it work? So you feed in 120 volts on this side through the primary coil to make the magnetic field, and out of the secondary side we only get 16 volts. How does that work? Well, it has to do with the ratio of the number of turns that are on the core on each side. So we have a certain number of windings or turns on the primary side, and we have a different number of turns on the secondary side. In a 16 volt NuTone transformer, the ratio between the primary voltage and the secondary voltage sides of the transformer is somewhere around, it's between 7 and 7.5 to 1. And what that means is, on the primary side, you're going to have 7 turns of wire for each 1 turn on this side. And if you divide it out, you'll find that somewhere between 7 and 7.5 to 1 reduces the 120 volts into 16 volts on this side. That's because, and the reason it works is because the primary side, it's making its magnetic field based on the number of turns. And on this side, you have a less number of turns, so there's less turns for the magnetic force to bleed into, to induce into. If it was 1 to 1, if it was 100 turns on this side and 100 turns on this side, if it was 120 volts in, it would be 120 volts out. But since it's less number of turns on the secondary side, you get less voltage out. And that's how it works. And that's what regulates the voltage that comes out of your NuTone transformer that powers your NuTone Intercom system. There's one other specification for transformers that is important to understand in a small way, but it doesn't really have a lot to do with what this video is going to show you how to do, but we'll cover it very briefly so you understand, or at least you're familiar with it. So transformers always have 2 ratings. They have their voltage and then they have their wattage. The wattage represents the power reserve or the power capability that the transformer is designed to supply. So for instance, a NuTone 301T is 16 volts and it's rated at 30 watts. And you can think of 30 watts just like a 30 watt light bulb. So in your house, again in your bathroom, surprisingly enough, you may have a very small 4 watt nightlight. And your little 4 watt nightlight is very small and it only puts out a little bit of light compared to a 30 watt light bulb, which would put out a lot more light. It's fundamentally the same idea. It's the amount of energy that the transformer can supply. And you can think of it this way. It's the wattage is the power reservoir of the transformer. So if you think of it as a glass, and if your glass is full, it's full with 30 watts. If you connect a device to your glass of 30 watts and your device is using 15 watts, then it's only using half of the reservoir of power and everything is happy. Because the transformer can keep the glass filled up with 30 and the device can use 15 of it and there's 15 left over and everybody goes home happy. Have if you hook a device to it that wants 45 watts of power, 45 watts would have to be theoretically way up here. Here's your 45 watts. The transformer can't make 45 watts. It's not designed to make that much power. It would have to be at least 50% bigger physically. You would have to take one of these and make it at least 50% bigger than this one is to be able to supply the 45 watts. So the transformer isn't designed, this 301T is not designed to produce or have the capacity of 45 watts. So it's going to work really hard, and it's going to try to make the 30, and it might make a couple more than that, but not very many. But it's not going to be enough to supply the 45 watts that the new device you've hooked up to it wants. And what's going to happen is, one, the device is most likely not going to work properly because it's underpowered. The power reservoir is too small, and in its attempt to supply all the power the device wants, your little 301T is going to start to get very, very hot. And transformers don't like to be very, very hot. I talk to a lot of people, and they'll call and they'll tell me, well, I've had a problem with my NuTone Intercom system, and I checked the transformer and it's very, very hot, so it must be defective. And it's like, no. Okay, and what I always say is transformers are usually the casualty of a problem with the device that they're powering. Now, if you have a 30 or 35-year-old NuTone Intercom master station and it's beginning to fail and it has other problems, as it begins to fail, it will demand more and more power than it typically would have when it was brand new. And the transformer will work really hard to try to supply that, but it can't always, or oftentimes not at all. And the transformer will get very, very hot. And it's not a transformer problem. That's why I made a video that was called Stop Replacing Transformers, because people needlessly replace their transformers because it's an easy thing to do and it seems obvious, but it's not. It's a problem with the device. Anyway, so that's sort of the fundamentals of how a transformer works and what the ratings of the transformer mean. Now let's go ahead and I'll show you how to actually test your transformer. Okay, so I've got my NuTone 301T. I've got it hooked up to my bench AC power supply, and it's turned off for right now. So here are our two halves of the transformer. On this side with the wires, this is what would get connected to the electrical wires inside your home on the primary side of the transformer. These are where the 120 volts get applied. And here on the other side, we have the two screw terminals where the wires from your NuTone Intercom master station will be connected. This is the secondary side. Now, a NuTone 301T is 16 volts at 30 watts. So what you want to do is, you need a multimeter. And I'm going to use my example one I use in other videos. This is my X-Tech EX330. I have a video about this. This is a good do-it-yourself weekend warrior multimeter. It's more than adequate for what most people will ever use it for. You can buy them street price, $30, maybe $35, buy it on Amazon, something like that. It's a perfectly acceptable occasional use multimeter. So NuTone transformers, all NuTone transformers are AC transformers. They're alternating currents. There are two kinds of electricity in the world. There is alternating current and there is direct current. Direct current is DC, and DC is just like the batteries that you put in your flashlight. One end is plus and one end is minus. Alternating current, no plus and minus, is just electricity. So the power coming into your transformer is AC, and the power coming out of your transformer is AC also. No DC here, always AC. So you have to take your multimeter. All multimeters have different voltage selections. Here we have volts AC and volts DC. So guess which one we're going to put it on? Wait. Okay, did you guess? Okay, we're going to put it on volt AC because that's what we're measuring is AC voltage. So we'll turn it on. We'll get it set up here so hopefully you can see it. And I'm going to turn my power supply on. Oh good, no sparks or flames. That's always positive. And all we have to do is take our probes. It does not matter which way you put the probes on the two screws. Okay. Oh, and this is another thing that I get asked all the time. Oh, will I get hurt doing this? Will I get electrocuted? No. We try not to get our customers electrocuted. Okay. We need all of you all the time, so no electrocution here. You can go like this. You can put your fingers on it. You can lick your finger, put your finger on it like this. Nothing's going to happen. It's only 16 volts. It's the same amount of voltage that runs your standard doorbell in a house. So it's nothing fancy. So what we're going to do is we're going to take our two probes and we're going to put one probe on one screw and one probe on the other screw, and we're going to read out what it says. And if you look at the multimeter screen carefully, you'll notice way on the left, kind of in the center, it says AC because we're measuring AC voltage, and it's reading 18.32. And you might be thinking, but he said it was 16 volts. Well, yes, but there's different ways you measure transformers. A 16 volt transformer like this is rated to output 16 volts AC under full load, under its 30 watt capability. Right now, this transformer is free running. It has nothing connected to it. So the voltage is going to be somewhat higher because when NuTone designed this transformer, they know that it's going to get installed into an intercom system that's going to be demanding power from it. So it's using up many of those 30 watts that it can create, and that's going to create a drop in the voltage. So free running, it's always going to be higher than what it is with a device connected to it. If we go back to that severely old 35-year-old failing NuTone Intercom system that's causing the transformer to get really, really, really hot, when you measure the voltage here with your probes, you might measure 9 volts. Because one, the device is demanding so much power that the transformer can't keep up, so the voltage drops and drops and drops and drops. Plus, it's probably burning hot, and hot transformers are not as efficient, and that makes the voltage drop also. So a free running transformer will always be more than what's specified on it. Unless, of course, you've got one of those super expensive NASA quality transformers, and then it might be dead on to what it says on the label. But for common class 2 transformers like this, it's always going to be a little bit higher, and that's just fine. Now, if you're in the mode of testing your transformer because you think there may be a problem with it because you're noticing or experiencing a problem with your NuTone Intercom system, there's 2 tests you have to do. So you have to do a test with the intercom connected and see what it says. And then you have to do a test with the intercom disconnected from the transformer so the transformer is free running. If you open up your intercom master station and you put your hand on the transformer and it's hot, and the way I always describe this to people is there are 3 conditions of transformers. First condition is it's stone cold. You put your finger on it and it's just as cold could be. Okay, that's a transformer that's probably turned off. Either there's no primary voltage coming into it, or the transformer has failed and it's dead and it's stone cold. That's number 1. Number 2 is it's slightly warm to the touch. You put your fingers on the metal part of the transformer, you'll notice no getting electrocuted here. I'm touching it all over the place, nothing going on there that's bad. So you put your fingers on it like this, and you think, and you close your eyes, and you stop talking for a second. And yeah, it's very slightly warm to the touch. That's good. That's what a normal transformer should be. Then the last condition is you put your finger on the metal part of the transformer, you count 3, 2, 1, and oh my God, it's hot, I gotta take my finger off. That's the burning hot. That's bad. Burning hot's not normal. You don't want burning hot. If your transformer is burning hot, most likely your intercom master station has some kind of fairly serious problem and it's overloading the transformer. To verify that, to prove that to yourself, because people don't always believe what I tell them, here's what you do. You take the wires off the secondary side of the transformer that connect it to the intercom system. You give it about an hour or so to cool down, and you should do that with the intercom opened up so it's got some air flowing around it and it can cool down. And once it's cooled down and you're back to that very slightly warm to the touch thing, okay, then measure it again. And what you'll probably find is the voltage has come back up, transformer is cooled down, and the transformer is happy again, and then you know the problem's over there with the intercom system. So that's sort of the fundamentals of checking your transformer behind your NuTone intercom system. Now, lastly, transformers sometimes can become what is called heat soaked. If a transformer has been hot for a really, 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 really long time. Months and months or years and years sometimes. The enamel on the windings inside the primary and secondary side, which is the enamel, is the insulation that keeps the little copper wires in the windings from actually touching each other. The enamel will start to break down and it becomes a very poor insulator. And it's as if someone took all those windings, which were originally all separated by the enamel, and crammed them all together as tightly as they possibly could. So they're not exactly all touching each other, but they're more touching each other than it was when it was brand new and the enamel was in good shape. It will become heat soaked. And heat soaked transformers sometimes never cool off. Even when you disconnect the device from them, they still will remain relatively hot. Even if you shut off the power on the primary side and let them cool down completely because they're shut off, when you turn the power back on, they will heat up again. I haven't seen that too often. I would say in the 32 years I've been doing this, I have only seen maybe a handful is 5 heat-soaked transformers, so it's not very common, but it can happen sometimes. Lastly, to give you all a little bit of confidence so you'll sleep well after you watch this video, almost all modern NuTone transformers are transformers that have been made since, say, 1974 and later, all have inside of them a device called a thermal limiter. A thermal limiter is a heat sensing switch, and it's usually on the secondary side, on this half of the transformer, and it does exactly what it sounds like. It's a heat sensing switch. So when the transformer is cold or very slightly warm to the touch, which is what you want, the switch is closed and electricity flows through it. When the transformer becomes too hot, the little metal arms of the switch start to warp, and they very slowly open up. And when they open up, it shuts the power off to the transformer, therefore allowing it to cool down. Now remember, transformers are always a casualty of the device that they're powering, so if the problem is with the device and the problem hasn't been corrected, once the transformer has cooled down enough, the metal arms of the switch will close again, the transformer will turn back on, and then it will heat up again, and when it reaches that magic hot temperature, the switch will open and it will shut off. This cycle will repeat endlessly until either one of 3 things happens. You disconnect the device, the master station, from the intercom that's causing the overload. The intercom system dies altogether, so it's not drawing any power at all, or the transformer finally fails. So there will be times that the switch is opening and closing because the intercom is in such bad condition. This is a safety device that was put into transformers to prevent them from severely overheating and possibly catching on fire. These transformers, these are called Class 2 transformers. As long as they're installed as per NuTone instructions, they are UL listed to be installed for the models that they go inside the wall housing behind the master station. A lot of older systems, pre-1984, these will be in a utility area, garage, water heater area, ceiling of a closet, for you folks that have attics, up in the attic that you can walk around in, some utility kind of area like that where they're out in the free air, but they're not, I've never seen a NuTone transformer catch on fire. I don't think it ever actually really happens. I actually have some NuTone transformers at my office that were made in the early 1940s, and they work just fine. So they're well-made transformers. So that's the ins and outs of how transformers work, how you check your transformer, what you need to check it with, and that's pretty much it. I hope you found this video to be interesting and perhaps helpful. If you did, please give it a thumbs up on YouTube, because that always helps. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell or on the wheel, put in your email address, and every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.